So I found this. Okay, so this is on Reddit. This is literally like the first time I've ever even seen anything on Reddit. Why is the set of real numbers said to be closed under division? If I understand correctly, for a set S to be closed under an operation star that takes two parameters x and y, x star y must be in S for all S and y in S. The set of real numbers are closed under division except for when the second parameter is 0. So why do people still say the real numbers are closed under division if it doesn't meet the requirement that S star y is in S for all x and y in S? If you say that it's closed under division because S star y must be in S only if x star y is defined, and that division by 0 is undefined, then shouldn't the set of all matrices be closed under multiplication? People don't normally say so. Okay? This deleted one I like because I hate it so much. Okay. I really appreciate where this is coming from because it takes us in directions. I think this is going to come down to how you are defining everything. If you define division with respect to multiplication, this depends on the existence of a reciprocal. Since 0 does not have a reciprocal, you cannot use it in division. It is not a valid operation. And this is the most philosophical response I've ever seen. Philosophers do this shit all the time. They'll just... something that they say is utterly broken by some other obvious fact that they also say, but then they'll just introduce a definition that makes it go away. So that is why I love this because I hate it. I simultaneously love and hate it. Because it is so just blatantly like, I don't give a fuck. Right? I'll just define this away. Right? If you're able to do that, then no question is worth asking, because you're always able to just pull this card and do that. That's why I hate this. But I also love it because I see it so often. So it is worth having such a transparent example of it. This next one, it's a significant response. So, and it goes in a slightly different direction. It sort of goes in the same direction, but it explains it more. Alright, the phrase closed under division simply means that every non-zero element has a multiplicative inverse. So he's clearly pulling this card, really. Basically, in any structure that has operations which can be called addition and multiplication, we call those structures rings, there are two special neutral elements. Neutral element for addition, we call this element 0. Neutral element for multiplication, we call this element 1. Connected to those neutral elements are the two concepts of inverse, the additive inverse and the multiplicative inverse. The additive inverse, blah blah blah, gives you 0 when you add the two things together. The multiplicative inverse gives you 1 when you multiply the two things together. Turns out that in rings, the multiplicative inverse of 0 never exists. The reason is that multiplying anything by 0 results in 0. So, it makes sense to ask two questions. In which structures does every non-zero element have a multiplicative inverse? Does multiplicative inverse have to be unique? Okay, so here he's taken that philosophical pill, but he's also explaining in some detail why it sort of makes sense that we should. I disagree with him that we should. Okay, we call structures in which all non-zero elements have a unique multiplicative inverse division rings. Not all rings are division rings. When the multiplicative inverse of x is unique, we denote the inverse by x to the negative 1. We call multiplying by the multiplicative inverse of x dividing by x. So, after all this discussion, back to your question, closed under division means that we can divide by any non-zero element because dividing by 0 is a non-starter anyway. So, if we insisted on including 0 in the closed under division expression, we would end up in a situation where no interesting structure is closed under division, which is kind of meh. So ultimately this is why I dislike this one. Because at the end of it, he's saying that basically we don't know what to do when you divide by 0. So if you included it, then it would just hurt our little brains and be boring. because we don't know what to do with that, so we would never have a complete structure that we can pat ourselves on the back for having. That's effectively what he's saying, right? This is basically like a solipsistic, narcissistic argument right here. He's saying effectively that we want to be able to say, look at this, we completed math. We did all of the math. Everything in the math up to this point, we perfected. We are gods. And if we ignore 0, then we can say that. But if we insist, where does he say it? If we insist on including 0, well, that's in the fucking definition, isn't it? Which is another place where it gets interesting. It depends how you define everything. You defined closure to be this. Under this definition of closure, it is not closed. You can't define your way out of that problem. Neither of these solutions, right? Here you just have the very, very standard philosophical, well, it depends how you define things, where they don't really know what the fuck they're talking about. And then this guy's like, so yeah, if we define it so that we ignore 0, then we become God. And if we insist on using 0, why would you do that? It just becomes boring. That's what's happening. It's effectively a tiny little psychological tantrum that they're having, because the claim that they want to make is fucking wrong, and they can't admit that because they're narcissists. They're perhaps solipsistic, but they're certainly narcissistic. They want to be correct in everything, whether they actually are or not. That's what's happening here.